Hi Sumaya, good evening.
Hi.
Okay, let's start with the recap and then we'll move on to the DBMS continuation.
Okay.
And tomorrow, I think we can do uh, two sessions maybe because I feel that. Do you think two sessions is better or just making the session for 2 hours is better with a break?
2 hours is fine for me.
Yeah, I think two times becomes like too much. You have to
Eh,
be available and stuff. I mean, you can study the rest of the day yourself and then in the evening kind of this recap stuff. Have you been practicing on the DBMS queries?
Yes, I practiced a little, but I didn't practice the advanced SQL. There's a
Okay,
lot. It's giving me a headache.
I know. User access, this, that. It's just too much.
Yeah.
Cool. Let's start. Okay, we start with the advantages of database management system. Um, so DBMS creates and manages databases. With the help of DBMS, programmers can easily retrieve, create, update, and manage data. And there are various functions performed by DBMS, which gives an upper hand over traditional file system. Users can also create personalized databases as per requirement. So ease of accessing data. In the file system, different files are created for each user, which users can access. DBMS removes this redundancy by granting access to users and decides which and how many parts of the data is accessible. Storage and management of data. Unlike file system, data can be directly stored in form of objects in DBMS, making it easy to query. So I think we are talking about the object-oriented database management system and not relational one, because in object-oriented we can store the data in objects. Avoiding duplicates and redundancy in the file system. Storage of data might happen multiple times. Data normalization is used in the database management system to avoid duplication of data. Concurrent data accessing, which means multiple users can access the database simultaneously. Database integrity, which means that data should be accurate and consistent. This is implemented by enforcing checks or constraints on the data while it is being entered or manipulated in a database. Data of a database is not allowed to violate these constraints or rules. For example, a constraint on age for an employee can be between 18 to 70 years only. While entering or modifying the data of an age of employee, a DBMS should enforce this constraint. So, a recap, ease of accessing different files, unlike the file system where there are different files for each user. In database management system, it decides what part of data is accessible to which user by granting them the respective access. Storage and management of data can be directly stored in form of objects, so that makes it easy to query. Avoiding duplicates and redundancy, unlike file system, there is no duplication of the data with the help of data normalization. And concurrent data accessing, which is multiple users can access the database simultaneously. Database integrity, which means that it enforces the constraints or rules, making sure it's not violated, and it should be accurate and consistent. Ease of access, storage management, avoiding duplicates using normalization, concurrent data accessing, and database integrity. Okay, types of database architecture, one is physical and second is logical. So, logical architecture, it defines the data organization and access at different logical levels of database. which is specifically talking about the three-level architecture of DBMS. Then you have the physical architecture, which mainly talks about the different components of the actual software. There's DML precompiler, DDL compiler, file manager, database manager, query processor, database administrator, data files, indices, and data dictionary. In logical database architecture, we have three-level database architecture. One is external view, which is the user view. Second is the logical view, and third is the physical view, conceptual level, sorry. So the three-level architecture of database was designed by ANSI for data abstraction for different types of users. You have physical or internal level, conceptual or logical level, and external or view level. So first is your physical or internal level that decides how the data is going to be stored. And the data is stored in the hard disks in form of bytes. This is the lowest level in three-level architecture. It describes how data is actually stored into the database. In the lowest level, the data is stored in external hard drives in form of bits. And at higher level, it can be said that the data is stored in files or folders. The physical level also discusses compression and encryption techniques. Conceptual or logical level, this is the second level, and it doesn't care how the data is stored. It's more concerned with the structure of the data and the relationship between different components of the data. So is a level higher than the physical level? Purpose of conceptual level is to define the structure, relationship, and the constraints of a database system. It describes how database appears to the users conceptually and the relationship between various data tables. It does not care how the database is stored. External view level. This is the highest level in the three-level architecture and closest to the users. This decides what part of the data is going to be visible to the users, because not every user has to view everything from the database. So it only shows relevant database content to the users in form of views and hides the rest of the data. So different users can see database in different view as per the individual requirement. Let's glance through the image or diagram. So you have external or view level, you have different users here, then you have the conceptual level, uh, and then you have the internal or physical level. This is the actual database. This decides where the data is going to be stored. This will decide uh, the structure of the database relationship, and also the relationship and the constraints of the database. And external view level doesn't care how the data is stored. This is going to be taking care of what part of data will be visible to the users. This is accessed by database administrator and system administrators. This is only accessed by users. Data independence and its relation with a three-level DBMS architecture, which is mapping between different levels. So data independence means that a change at one level of the database should not affect the other. So data independence means that change of data at one level should not affect another level. So we should be able to modify the schema at one level of the database without altering the schema at the next higher level. The three-level architecture defines a single database system across all three levels. Therefore, different levels must map with each other. This mapping leads to the concept of data independence. There are two types of data independence. One is physical data independence, which is defines at the capacity to change the internal schema without having to change the conceptual schema. If we do not change in the storage size of the database system server, then the conceptual structure of the database will not be affected. It is used to separate the conceptual level from internal levels. So one is the physical database independence occurs at the logical interface level. Okay, so physical database independence, which means capacity to change the internal schema without having to change the conceptual level schema. If we change the storage size, that should not affect the structure of the database. It is used to separate the conceptual level and the internal levels. Physical data independence occurs at the logical interface. When you have the logical data independence, it refers to the characteristics of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external level from the conceptual level. If we do any change in the conceptual view of the data, then user or view of the data will not be affected. Logical data independence occurs at the user level interface. Physical architecture defines a software component used to process and enter data and how these software components are related and interconnected. There are a number of key functions which are similar to most database management systems. The components that normally execute these functions are shown here. So you have general users, application programs, object code of program, DML compiler, query processor, DDL compiler, database manager, file manager. When the query executed, it is taken care by the query processor, then database manager, then file manager, and then it comes to the data files and gets the data from there. You have database administrator, schema, DTL compiler. So that's your physical database management architecture for different components. So first is DML precompiler. Every DBMS consists of data manipulation language, which is used for data insertion, modification, and data access. The purpose of DML precompiler is to translate DML commands, which are written as part of the application programs, into related procedural calls so they can be executed to perform desired operation. As a translation component, DMS also coordinates the translation data which are input to the DDL component. It is used to compile the DDL statement into related tables, which includes the metadata, constraints, access rights, etc. The metadata tables are stored in dictionary or system catalog. This metadata is used for providing information about tables to other components of DBMS, protecting data, enforcing data integrity. So precompiler translates DML commands so they can be executed to perform the desired operation. DDL compiler is used to compile this DDL statement into related tables. Then you have file manager, all the tables and metadata of the database. Uh, One second. The file subsystem of the operating system has generic features which may not be sufficient for database management system file. The file manager component of DBMS keeps track of all the data files, their index files, and other related information files of the database system. The role of database management is to manager is to accept the request of the data or data manipulation by the user queries and application programs and performs the relevant actions on data taking the help of data dictionary and file manager. Database manager protects the data from unauthorized access and manipulation. It also enforces integrity constraints. The file manager keeps track of all the data. Database manager accepts the request of the data and performs the relevant action, protects the data, and enforces integrity constraints. Major components of database manager. Authorization control is used to verify the credentials. Command processor converts DDL or DML or other programming language commands to executable sequence of code. Integrity checker checks if the data is being inserted into the database or is being modified, follows all specified constraints. Query optimizer tries to optimize the processing time of the query. Transaction manager checks if the user has a right to perform a transaction. Scheduler component manages consistency of the data. Recovery manager is responsible for recovery of the database system to a consistent state. Buffer manager optimizes the process of transfer of the data between the main memory and the disk. It's also termed as cache manager. Every DBMS consists of a query language that enables database creation, manipulation, retrieval, and control operations. In general, query languages processes consist of the two basic components. The first one passes the query into the native database language, and the second one optimizes the query and prepares it for execution. The parser checks the syntax of the query, converts the query to a sequence of tasks, and sends these tasks to the query optimizer. The query optimizer is responsible for generating a set of alternative query evaluation plans. Database administrator, the role of DBA is to monitor control of the database creation at different levels of three-level architecture and mapping between different levels, modifications, access, query response time, security, recovery in case of any failure. Data files, the data is stored in the data files. Data files can be standard files or encrypted files. These files in general are not accessible directly to the system user. Indices are stored in the index files. They provide fast access to the items. Data dictionary is designed to store metadata, which is the data about data. A good data dictionary allows efficient data access as it provides a roadmap to guide users to access information within a large database. A database system requires that data should be structured in such a manner that it allows easier access and manipulation. Their structures are termed as database models. Conceptual model uses entities, attributes, and relationship. Hierarchical model uses data hierarchy. Record-based logical models, object models, semi-structure model, and then database backend is most of the database systems are deployed in a multi-user environment, either as centralized or distributed system. A database server which is a backend manages and controls the physical data. It also provides integrity, security, and access control to multiple clients' requests. What is the need of utilities in commercial database system? Well, utilities are special purpose software which are provided to support additional features in support of DBMS. Two such utilities are for backup or restore to protect data against any failure and load or unload the data from one hardware or software. Sonia, can you read this? I'm tired of it.
Okay. Difference between network and hierarchical models. A network model stores of basic entities as data records, and points are used to represent the relationship between them. A hierarchical model uses almost similar model to represent data of entities, but the relationship between them is implied as a hierarchy.
So, okay, go on.
A relational database management system, an RDBMS, is based on the relational model introduced by EF Code, for example, SQL, MS SQL Server, IBM DB2, Oracle MySQL, and Microsoft Access are RDBMS. An RDBMS database uses tables to store data. Each table is called a relation, which is a collection of related data entries and contains rows and columns. Each table represents some real world object, such as person, place, or event about which information is collected. Following are the important differences between RDBMS and ODBMS. RDBMS stands for Relational Database Management System. OODBMS stands for Object Oriented Database Management System. Data is stored as entities defined in tabular format in RDBMS. In OODBMS, data is stored as objects. RDBMS handles simple data. OODBMS handles large and complex data. In RDBMS, an entity refers to a collection of similar items having the same definition. In OODBMS, a class refers to a group of objects having common relationships, behaviors, and properties. In RDBMS, it handles only data. OODBMS handles both data and functions operating on that data. RDBMS objective is to keep data independent from application program. OODBMS objective is to implement data encapsulation. In RDBMS, a primary key identifies an object in a table uniquely. In OODBMS, object ID OID represents an object uniquely in a group of objects.
We'll do a recap. So RDBMS is based on relational models. It's introduced by EF Cord, and examples of that are SQL, MS SQL Server, IBM DB2, Oracle MySQL, Microsoft Access. A relation database uses tables. These tables are called relations, which contains the rows and columns, which are basically collection of related data entries. Each table represents some real-world entities, just person, place, event, about which the information is collected. Difference between these is uh, RDBMS stores the data as entities in form of tables, and ODBMS stores in form of objects. RDBMS handles simple data. ODBMS can handle large and complex data. RDBMS an entity refers to the collection of similar items having the same definition. A class refers to the group of objects having properties and methods. So RDBMS is mainly to do with entity. ODBMS, works on class basis. This works on entity in tabular format. This works on data as objects because it deals with class. RDBMS handles only data. OODBMS handles both data and functions that are supposed to be operating on that data. RDBMS keeps the data independent. OODBMS implements the data encapsulation. RDBMS has a primary key. OODBMS has an object ID or OOID. Okay, go on.
Database relation example. Each row of the table is called a record or tuple. Each column is called an attribute that represents values, for example, employee ID, employee name, post salary. A domain is a set of permissible values that can be accepted by a specific attribute. For example, the attribute salary can accept values from 5,000 to 100,000. The smallest unit of data in the table is the individual data item or cells. For example, Rahul Clerk, 20,000. The total number of attributes that comprise a relation is known as the degree of the table. For example, the employee table has 4 attributes and its degree is 4.
What's the degree of relation? Do you know?
And degree is the number of columns.
Yeah, I think degree of relation, degree of table is the same thing, if I'm not wrong. It's the number of attributes.
Yeah. A superkey is an attribute or set of attributes used to identify the records uniquely in a relation. For example, empid is a superkey since empid is unique for each tuple or record. Similarly, empid plus ename and empid post are also superkeys of the relation employee since their combination is also unique for each tuple or record. A candidate key is a single key or a group of multiple keys that uniquely identify rows in a table. For example, both emp ID and name can act as a candidate key for the table as long as they contain unique and non-null values. The difference is that candidate key is not reducible, which means you cannot remove one of the attributes and then the remaining attribute is still unique. Primary key is a candidate key selected by the database administrator to uniquely identify tuples in a table. Out of all the candidate keys that can be possible for a table, there can be only one key that will be used to retrieve unique tuples from the table. For example, if empid and name are candidate keys, then empid can be chosen as a primary key.
Uh, can the candidate key be a combination of the two uh, attributes? Like, for example, em, id, and ename. Can that be a candidate key clubbed together?
No, no, because empid alone can be a key.
Hmm.
So uh, for the candidate key to be non-reducible, it should be as small as possible.
Okay, I think I should add that.
Uh, you wrote that, right?
No,
Candidate key is not
I
reducible.
didn't write. Yeah, I mean, I'll explain a bit, a little more in it,
So basically, it shouldn't have any extraneous attributes.
which means you cannot remove one of the attributes. Means after removing, hard to explain this part. Should not be able to be unique. Your ID plus email. Hopefully now we'll understand. Okay. One.
Relation. A relation is defined using two basic aspects. Relational schema specifies the relation's name, the list of attributes of the relation, and the domain of each attribute, which is denoted as R brackets A1, A2, AN. The relation R has n attributes, which is also called the degree of a relation. For example, the relation schema of the relation person can be defined person person ID, integer name, character, age, integer, address, character.
So this is what I was talking about. Like when we're writing the relation schema, we are also specifying the type of that particular attribute. But in the
Mhm.
example you mentioned and in the book, at many places they are not specifying the type. So is it okay to leave the type?
I don't know. In the book, they haven't specified the type.
Okay.
Since the person relation contains four attributes, so this relation is of degree 4. Relation instance or state is a collection of tuples for a given relational schema at a specific point of time. A relation state R of the relational relation schema R A1, A2 to N, also denoted by small r, big R is a set of n tuples. R is equal to T1, T2 up to Tm has m tuples, where each n tuple is an ordered list of n values. A T equals V1, V2 up to Vn, where each Vi belongs to domain Ai or contains null values.
Okay, so this is relation schema for student. This is the schema, and this is an instance. Instance. So difference between the schema and instance is that schema contains the relation name, for example, person, and the list of attributes it has. These guys, columns. And relation instance is basically a set of tuples, set of rows at a given point of time. In this case, R equals T1, T2 up to Tm. So that's our number of rows, T1, T2 up to Tm. Okay, let's try this. What are different attributes of relation S and how many tuples does S have? So different attributes is S number, S name and city, and number of tuples is 2. Okay, yeah. What are the domains of the attribute S? So domain of attribute S could be starting from S and going up to S1, S2. So it's a set of it's a character basically. Let's see. Domain of SNO is codes that are being assigned to the suppliers. The present coding uses first character as S followed by a sequence of numbers for the supplier. Domain of S name is a string of characters of some defined length, and domain of the city is a set of possible cities in India. On sorting this relation on the field city, will the relation change? Will the order of tuple of the relation change? So when if you sort this relation on the field, will the relation change? No, the relation will not change. But yes, the order of the tuple will change. List the super keys, all possible candidate keys, and the primary keys of the relation. So super key is S number, S name, S name, S number plus S name, S number plus city, all possible candidate keys. So candidate key cannot be reduced. So then S number should be candidate key. Primary key is S number. What would be the candidate key, Sumaya, in this?
S number or S name could be assuming all the names are unique.
Okay. Super keys is all possible combination. Candidate key is S number, S name, never as long as they are unique. Of course, you have to put a clause there when we're writing answer in exam. Primary key is S number. Okay. Relational constraints and types of constraints. On modeling the design of a relational database system, we can put some restrictions like what values are allowed to be inserted, modified, deleted in a relation. These are the restrictions we impose on relational database, and these are called relational constraints. These restrictions that we impose on the relation database system is called relation constraints. Constraints of following types: domain constraints, key constraint, integrity constraint. So, a recap, basically, when we are creating the relational database system, then we put some constraints or restrictions on what will be allowed and what will not be allowed while inserting, deleting, or modifying the data in the relation. These restrictions that we impose on the database system is called relational constraints. These are of three different types: domain, key, and integrity constraints. First is domain constraints. These constraints bind the possible values of the attribute in relation to specific set of a given data type called the domain of the attribute. Every domain must contain atomic values, which means that it cannot be further subdivided. This means composite, which can be divided into subparts, and multi-valued attributes are not allowed. So this is an example. In above relation, name is a composite attribute because there is a division. Composite means you can divide into parts. Phone is a multi-valued attribute, so it's violating the domain constraints. So both are violating, correct? Both name and phone are violating the domain constraint because constraint is saying it has to be atomic. So name cannot be both because in that it has to be just right now.
Yeah, it says composite and multi-valued attributes are not allowed.
Okay. Key constraint. The constraint states that key attribute value in each tuple must be unique. No tuples can contain the same value for the key attribute. So if we choose a key, then it cannot, I mean, other tuples cannot have the same value. So each tuple should have unique key attributes. This is because the value of the primary key is used to identify a unique tuple in a relation. In the below example, if the EID is the key attribute, then the first and the last tuple violate this rule because they should be unique. Integrity constraint. These
Also,
are of
the
two
key
types.
constant should be non-null. That's not
Okay,
mentioned here.
let's add that.
Oh no, sorry, that's the entity integrity constraint
Okay.
that specifies that a primary key should be non-null.
Okay, integrity constraints. These are two types: entity integrity constraint and referential integrity constraint. This states that any attribute of a primary key cannot take a null value. This is because the primary key is used to identify individual tuple in relation. You will not be able to identify the records uniquely if they contain null values for the primary key attribute. In the below example, if A is primary key, the first record or tuple violates the entity constraint rule because it's null. Then you have referential integrity constraint. This constraint is specified between two relations or tables and used to maintain consistency among tuples in two relations. It is enforced that through a foreign key, when an attribute in a foreign key of a relation R1 has the same domain as the primary key of the relation R2, then the foreign key R1 is said to refer to the primary key of the relation R2. In the example below, every value of C in instance R, so instance is a set of tuples at a given point of time. So every value of C in an instance R is matching with the values of C in instance S in some tuple. So these values match with these values. The R contains the values C1, C2 up to C5, and S contains these values. Thus, instance R and S does not violate the foreign key constraint. Okay. So they should be present here. Basically, for example, let's say we have a C6 here and C6 is not here. So then it's violating. But all of these guys are present. Okay, so I'm going to just give a recap on this one. So relation constraints. So we impose some constraint or restrictions in the database, and this restriction that we impose is called relational constraints. There are different types. Domain. You have domain constraint. We have key constraint, and we have integrity constraints. In domain constraint, it states that uh, the attribute will have a set of values which will be from that given range and of a specific data type, and the value should be atomic, which means it cannot be subdivided into different parts, and the value should not be composite or multi-valued. In this example, because name and phone number are composite attribute, and of course phone number is multi-valued, then that's why it's violating the domain constraint. So let me just underline this part. Bind the possible values of attribute to a specific set. Okay. Now, key constraint. In key constraint, we should not have none of the tuples. Yeah, in key constraints, the key attribute should be unique. So, uh, no two tuples can have the same key. So, in this example, because the first tuple and the last tuple is the same key, it is violating the key constraint. Integrity constraint. Stay, there are different types of integrity constraint. One is entity integrity constraint, which states that none of the tuples will should have a null value in the primary key. So primary key should not be null, because that is used to uniquely identify the tuple, and if it's null, then we won't be able to identify it. And then you have referential integrity constraint. So in referential integrity constraint, we have a primary key and a foreign key, and the primary key should be present. The primary key of an instance R should, for example, should be present in the foreign key of instance S. So this constraint is specified between two relations or tables and used to maintain consistency among the tuples. It is enforced through a foreign key when an attribute in foreign key of relation R1 have the same domain as the primary key of the relation R2. Then the foreign key of R1 is set to refer to the primary key of relation R2. Every value of C in instance R is matching with the value of C in instance S in some tuple. The R contains the value C1 up to C5 and S contains all these values. Thus, instance R and S do not, does not need do not. Instances R and S do not violate the key constraint. Let's move on. Why constraints should be defined in the database management system? Defining constraints prevent bad data from being entered into the table of interest. I think another could be there are no duplicates. They enforce business logic at database level. They provide documentation of important database rules. They enforce relational integrity between any number of tables. They improve database performance. They enforce uniqueness. Okay, so prevent bad data, enforce business logic, smally, provide documentation, enforce relational integrity, improve database performance, and enforce uniqueness. Okay, dealing with constraints violation. Constraints violation can occur during the following data update operation. Handling constraint violation during insertion of tuples. If the insertion violates one or more constraints, then two options are available. Default option insertion can be rejected, and the reason of the rejection can be explained to the user. Ask the user to correct the data and resubmit, and give the reason for rejecting the insertion. So this is an example of a relation person. These are the attributes, these are the tuples. If the user tries to insert all of these data into person, it's violating, we're giving the message to the user saying violated constraint, key constraint reason, primary key 1 already exists here, and it's trying to insert that key again. How to resolve? DBMS should ask the user to provide a valid personal ID value and accept the insertion if the valid personal ID value is provided. So this talks about how to handle these violation at different operations. Let's say insertion. If he's making a mistake, then tell him, you know, what type of violation it is, what's the reason, how to resolve it. Handling constraint violation via during deletion of tuples. Default option rejection. Reject the relation. It is the job of DBMS to explain reason why it's rejected. Attempt to cascade the deletion by deleting tuples whose foreign key references the tuple that is being deleted. Change the value of the referencing attribute that causes the violation. Handling constraint with during update of tuples. The constraint violation faced by the operation are logically the same as the problem faced by insertion deletion operation. You may define these actions yourself. Now I talk about relational algebra. Relational algebra is a set of basic operations used to manipulate the data in a relation model. These operations enable the user to specify basic retrieval requests. The, the result of the retrieval is a new temporary relation, which is computed after performing these operations on one or two relations. Some of these operations can be classified in three categories. One is relational operation. These can be unary operation, selection, projection, binary operation, Cartesian product, join. We're talking about relational algebra, which is some basic operations used to manipulate data. Result in new temporary relation. These operations have different types. One is relational operation, unary and binary. Let's see. Then you have basic set operations. These are binary operations used to merge two sets in various ways. Two relations are said to be union compatible if they have the same degree n and domains of the corresponding attributes are also same. Union intersection set difference. And last one is assignment operation, rename and other operations. Can you read this, Sumaya?
Selection is a unary operator that is used to choose only those tuples from a relation that fulfill a given criteria. It is represented using the mathematical symbol S as given below. Selection condition on relation. Oh, this sigma, the symbol it's called sigma, I think.
Yeah.
For example, select place uh,
Hmm.
equals Mumbai or salary is more than whatever this is.
10 lakh citizens.
Select age less than or equal to 30 on person.
So consider a
For one
relation
person.
person if you want to display details of a person having age less than equal to 30, then selection operation will be used as follows. Age less than equal to 30 on person. The resultant relation will be as follows. Person 2, name, age, address. Selection operation is commutative, hence you can apply a sequence of selection operation in any order. So you can combine them also. You can apply more than one conditions by using logical connectors. So this is going to give you like a new temporary relation when you're using this selection. And I haven't tried it, but it's just in the textbook. Go on.
The projection operation is used to select specific attributes from amongst all the attributes of records. This is denoted as pi. Projection is used to project required column data from a relation.
So if you use projection operation, for example, on the attribute name for a relation person, the result will be created like this. You know that the projection operation, this equals this, provided list contains attributes in the list. Okay, Cartesian.
Cross product between two relations, let's say A and B, will result in all the attributes of A followed by each attribute of B. Each record of A will pair with every record of B.
So let's see how this is doing it. You have names, age, sex, ID, and course. So it's a RAM, and then it's doing this. It's adding this one, and then again for RAM, it's adding this one. So it's going to repeat this until all the columns are all the records are exhausted here. all the tuples are exhausted. Okay, so it's going to set this. So combine is going to combine both the columns, this column, these three, and these three, and then it's going to start from here. It's going to start from first, this multiplied by all of these. So it's going to keep adding those until this finishes. Then it'll move on to this one. Again, keep adding those these tuples. That's how it products is. If A has n tuples and B has m tuples, then A and B will have n into m tuples. So this will be a total of 3 into 2, which is 6 tuples. That's 6. So Cartesian means cross product. Okay, are you there?
Join, yeah. Join
Okay,
operation
one.
combines the relation R1 and
Yeah.
R2 with respect to a condition. It is denoted by this symbol. The different types of join
Mhm.
operation are as follows. A theta join. A theta join combines tuples from different relations provided they satisfy the theta condition. The join condition is denoted by the symbol theta. Equijoin. When theta join uses only equality comparison operator, it is said to be equijoin. Natural join. At least one common attribute should exist between two relations, and the attributes must have the same name and domain.
So we'll discuss in detail about this different join. A lot of important chapter on that. We'll discuss that later.
A union operation. The result of union operation, which is denoted by A union S, is a relation that basically includes all the tuples that are present in A or in S or in both, eliminating the duplicate tuples. Intersection operation. The result of intersection operation, which is denoted by A intersect S, is a relation that basically includes all the tuples that are present in both A and S. Set difference or minus operation. The result of set difference operation, which is denoted by A minus S, is a relation that basically includes all the tuples that are present in A but not in S.
So just a recap. In union, you have the tuples present in A or in S or in both. Okay, so it's or. Union is like or. It should either this or this or both. Intersection means it has to be present in both. Set difference means it's present in A but not in S. That's why A minus S. Just fix this. Nice. So tomorrow we'll do entity relationship model. Done. We've reached like 44, and there are a lot more. Hopefully we can cover this week. We can finish this week. Okay, now we'll do a quick recap of the object-oriented programming, and we'll start with the data types in Java. Okay, so the different data types in Java, let's try to recall it. So you have primitive data type, which includes int, long, float, double. Uh, what are the others? And then you have
Character,
character.
byte,
Okay, byte, fine. And then apart from that, you have the user-defined data type, which includes arrays, classes, interfaces, classes, interfaces, arrays. Let's wait for 2 minutes now because prayer is going on. I think for tomorrow we can start at 4:30 because it's a weekend, so it's a free time basically. So I think we can start 4:30 so we can finish it by 6:30.
Yeah, sounds good.
Okay. So yeah, let's move on. Primitive and non-primitive. So I missed Boolean, I think. Char, byte, short, int, long, float, double. I missed Boolean. Classes, interface, arrays. Yeah, this was bang on. Let's see if we can remember this. So character, how many bytes are there in character? Uh, 2 byte. Boolean is one bit. Byte is 1 byte. Short is 2 byte. Int is 4. Long is 8. Float is 4. Double is 8. Okay, so int and long 4 and 8. Float and double 4 and 8. Boolean is 1. Char is 2. Byte is 1. Short is 2. Okay. Default values Boolean is false. Char is backslash u 4 times 0. All these are 0. Only long ends with L. Float ends with F, and double ends with D. Okay. In the examination, when they ask, do we also need to write like the range of these guys?
I don't know.
Okay.
Is it mentioned in the book?
I mean, we have to describe. I'm not sure about the book because I've picked up these from another site, but where we have to describe about them, I guess it's enough to describe about their values and size, I guess.
Yeah.
Okay, non-primitive data types. We can probably expand on these guys. This will be good. We can write some content here. Okay, classes. Classes are the blueprints which are used to create objects which have properties and methods. Interfaces. Interface is a blueprint of a class, and with interface you can achieve multiple inheritance, which is doesn't exist in Java by default, and it contains static constants and abstract methods. It is used to achieve abstraction. By interface we can support functionality of multiple inheritance. It can be used to achieve loose couplings. Loose coupling in abstraction. Okay, non-primitive data types. Then we talk about arrays. So array can be single dimensional, multi-dimensional. Single dimensional array is a list of the data items stored in a contiguous memory location. A single dimensional array can be accessed with the help of index, and this is how you basically instantiate it. Sorry, declare it. Int a equals new int the size, and then you can assign these values and you can loop through it. Similar data type is important to mention. We can store only the fixed size of elements in an array. It doesn't grow its size at runtime unless you use dynamic arrays. Single dimensional array, a list of variables of similar data type, access using index. Int my num equals, we can assign the value directly like this, or we can basically declare it like that, new int the size of it. Multi-dimensional array, which contains uses more than one index to access array elements. So it's an array of arrays. Okay, so two things: array of arrays and uses more than one index to access array elements. Okay, so this is an example of a two-dimensional array. You say int square brackets 2 times name of the variable equals new int and the individual sizes, and same thing goes for 3. Difference between a static array and a dynamic array. Static array are declared before runtime and assign values while writing the code. Dynamic array is declared while writing the code and memory is allocated at runtime. So static array declared before runtime, dynamic array is declared while writing the code. Memory is allocated at runtime. This is the example int array, and then assigning the value. Declared. I think there's a problem here. It should be arr, not array. Int array equals new int 3 dynamic integer array.
I don't think
This
that
wrong.
example is correct in Java.
Yeah. Can you quickly get the correct example of static array and dynamic array? Let's update this guy.
So dynamic array, I've only found out that you can use array list or you create your own dynamic array class.
Did you get an example?
Let me check.
Okay. See, I found that information. I think from here, I'll show you.
Oh, my
See,
computer froze.
oh, okay. See, look at this one. This is an example.
Yeah.
Is this correct?
The static array one looks correct, but dynamic array there are no pointers in Java, so it
Mm-hmm.
doesn't look right.
Okay.
So this example, I found they've created a whole new class.
Like using array equals new int, using new operator, new keyword.
Um, can you see the link I sent?
Okay. I'm on the same one.
Oh, same.
This one, now you're talking about this
Yeah,
guy. Yeah.
but that's only part of it. It's part of one of the methods in the dynamic array class, right?
I mean, if I pick up this guy, is complete, right? Declaring, initializing, and adding.
No, I think maybe from the next below that there's a program uh, that shows an example. This one,
Hmm.
where they've used the class that they created.
This is too big for an example. It's too big.
Yeah.
The upper one is fine, I think. It's also an example of initializing a dynamic array.
Okay.
Okay. First one is correct, right?
Yes.
Okay. It grows automatically when we try to insert elements if there no more space left for the new element. It's located in stack memory space. It's located in heap memory space. Okay, program to print the sum of all the array elements. So int array, uh, new int 1 2 3 4 5 int sum equals sum plus array. The Unicode, a 16-bit character encoding standard, is capable to represent almost every character of well-known languages of the world. For Unicode, there were multiple standards to represent character encoding. Some character was using single byte, some tool to support multinational application codes, and even same code may represent a different character in one language and may represent other character in another language. So to overcome our shortcomings, Unicode system was developed where each character is represented by 2 bytes. As Java was developed for multilingual languages, it adopted the Unicode system. So the lowest value represented by backslash u 4 times 0 and highest value is represented by backslash u 4 times f. Variable is like a container which holds values. It's a reserved area allocated in the memory whose value can be changed. You have local variables. So local variables are the variables which are inside of the body of a function. They are known to only that function, and outside world does not have any information. It doesn't leak out of that particular scope of that function. And local variable cannot be defined with static keyword. You have instance variables. Instance variables are those variables which are declared inside of a class but not inside of the method body, and they are available anywhere in the class. And as long as they are not declared as private, you can use them, inside of the class or even outside into another child class. It is not declared as static. If it is declared as static, then it will be called static variable. It won't be called instance variables. It is called instance variable because its value is instance specific and is not shared among instances. Static variable declared as static is called static variable. It can be used outside of the class without instantiating the class. It cannot be local. You can create a single copy of the static variable and share it among all instances of the class. So no matter how many objects you create, the value will be the same for that variable. So it can be shared. Memory allocation only happens once. So no matter how many objects you create, the allocation of the memory happens only one because it can be shared between multiple objects. Operators. So we have unary, arithmetic, logical, relational, bitwise, shift, ternary, assignment. Unary operator means plus plus, minus minus, postfix and prefix. Arithmetic is addition, multiplication, division, subtraction. Shift is greater than 2 times, less than 2 times. Relational is comparison, equality. Bitwise is bitwise and bitwise or. Logical is logical and logical or. Ternary is the one you write in a conditional statement in a single line. Assignment is if you assign a value. Statements and expressions. Each statement is a complete unit of execution. For example, int score equals 9 into 5. This is a whole statement. Expression could be like 9 into 5. Here we have statement complete execution of this state. This statement involves multiplying integers 9 and 5. and then assigning the result to a variable score. In the above statement, we have expressions 9 into 5. In Java, expressions are part of statements. So, difference between the statement and expression is that the statement is a complete unit of execution which ends with semicolon. An expression are part of statements. We can convert an expression into a statement by terminating the expression with a semicolon. These are known as expression statements. For example, number equals 10 is an expression. This is a part of a statement. A number equals 10 semicolon is a statement itself because it's a complete unit of execution. In the above example, we have expression number equals 10. Here, by adding semicolon, we have converted the expression into a statement. Java expression consists of variables, operators, literals, and method calls. Example, in score 90. Here, score equals 90 is an expression that returns an integer. And double A equals 2.2, B equals 3.4, result equals A plus B minus 3.2. Here, A plus B minus 3.4 is an expression because it's a part of a statement. If number 1 uh, double equals number 2, system out print ln. Here, number 1 double equal number 2 is an expression that returns a Boolean value. Number 1 is a larger than number 2 is a string expression. Java scanner classes. The scanner class of Java util package is used to read input data from different sources like input stream, users, files. So class is used to read the data, input data. So this is an example. We import the scanner class from util package. We say scanner input equals new scanner system.in. And I think we should just try to do this because I think it's an important one. Do, 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 do. IntelliJ. Yeah, we should do this one. So at least we practice it. We'll try to do it without looking, and if you're not able to do it, then what happened? Why is the Java one not opening? Yeah, okay. So let's create a class. What should we make it as? Okay. So inside of source, we'll create a class. Let's say read input. Okay, so we create a class. We'll import the scanner. Increase the. We'll import the scanner class. Import java dot util dot scanner. Okay, and then this will have a main functions of public. Will it be public or private? Public static or private static?
It's public.
Public static void. It's not going to return anything. Main, and then what else he has? Is it array? Args?
It's array of string square brackets.
String. Small letters? Why is it
No,
like
without the array, just string.
that's it or should something else? Args? I
Yeah,
think so.
I don't think there's a dollar.
Yeah, correct. Okay, now next is inside of the function. I want to instantiate this scanner class. So I'll say scanner uh, scanner equals new scanner, and this is going to take system.in. Yeah. and then we'll print it. So system dot print. What is that? System dot println.
System.out.println.
Println. Please enter a. What are we trying to do? Text. Okay. Your text. Text. Why is it underlined? So many characters in string literal. Okay. Then we'll say scanner. We have to hold this into a variable, right? Yeah. Yep. Text equals new string. Uh, no, this will be input actually. Scanner dot next.
Next line.
Fine. Yeah. Okay. Next line. So now we have to print this text basically, right? You entered. How do I add this? Is it dot
With a plus.
plus sign? Okay. Do I have to close anything? Have I done it correctly? Have I missed anything?
I don't think so.
Oh, okay. World. Okay, you entered hello world. I'm going to do this one more time so that we remember it. Scanner system in scanner dot next line. Okay. Okay. Differentiate scanner, or let's call it input this time, or user put equals new scanner system dot in, and then system dot out dot println, enter your text or enter your name, and then user in uh, string, user input we'll hold it in a name variable, user input dot next line, and then system oops, system dot out dot println your name is plus. That works. Let's remember this. Okay, I'm not going to go over it because you already done it. Precision and loops. We'll complete this. Decision making statement, if else statement, again, we don't have to go through explanation. Switch case statement used to select one statement from multiple code blocks for execution. Dump or branching statement used to skip statements within the loop or stop the loop instantly without evaluating the text condition. Used with for, while, and do while switch. Transfer flow of the control of the program. Three types of jump statements: break, continue, and return statement. Break statement, exit from the loop, continue, skip the current iteration. While loop we already know, do while we know, for loop we know. Program to display 1 to n numbers, util scanner, scanner SC. Hey, this is not correct. What this, like, there should be a dollar sign. We put dollar sign.
No, that doesn't need to be.
Okay. Didn't give me any error though. Hint number, scanner system, take the number from the user, print the number. Okay. Okay, I think we'll do assertion and exception handling tomorrow. Where are we? Okay, nice. We reached till 88. Hopefully by the end of the weekend we should be able to finish all. Okay, thanks, Samaya. I'll see you tomorrow at 4:30.
Yeah, thank you.
Bye bye.
Bye.